So we're going to finish up our examples for the LCM and the GCF, and then we're going to move into some common denominator stuff. So on example number 11, again, I always start with the prime factorization. I don't forget to bring down my variables, and I put it in a box. 3 times 17, 17's prime, and I put it in a box. So these were relatively easy to just write the prime factorizations. And now I want to go and do the GCF and the LCM. So for GCF, of course, it's got to be in both boxes here. So I see a 2 in both boxes. That's nice. But I don't see an 11 in both boxes. I can't use the 11. Here's a K over here, and there's a K over there. Good. There's a K, and I'm going to put the lowest exponent I see on him, which is to the second power right there. That's good. LCM. Now I'm writing every single base I see. I don't care if it's not in both of them. And I am only going to write the base once. So I see a 2 over here. Got it. I see an 11. Got it. And I'm going to take care of my numbers. I go over here. I've already got the 2, so I'm not going to write him twice. And I see a 17. Now I've gotten all the numbers. I'm going to go back, and I see a K. Yep, got him. Yep, got the K. And I got to add the G, and I got to add the H. So now I've got to go look and see what exponents I have going. Of course, 2, 11, and 17 are all to the first power, so it's really just the variables that I'm worried about for the exponents. I see a K to the 4th and a K squared. For the LCM, we take the highest. G, the only exponent we have on G is 2, and H, his exponent is 1. So I don't have a calculator, and I'm not going to take the time to do the arithmetic here, but whatever 22 times 17 is, would be the numeric part of your answer, K to the 4th, G squared, H. So you guys stop the video, do number 12, and we'll go over it when we come back to class. I kind of got the notes mixed up here, so if you will go find, when you flip over on the back, this is actually over to the right where example 11 and 12 is. So I kind of mixed these pages, but you can still see where I am. So we're going to talk about common denominators. We're going to talk specifically about lowest common denominators. And all of this is leading up to the fraction work that we're going to do in the next chapter, in chapter 5. So if you think of some common denominators for this fraction, when you're thinking about a denominator, of course, you're only thinking about the 3 and the 4. I don't really care too much about the 2 and the 1 when I'm thinking about common denominators. So when I am thinking about common denominators for these two guys, I'm really asking myself, what are the common multiples of 3 and 4? So the first multiple of 3 is 3 and then 6, and we can list the multiples of 3, and we can list the multiples of 4, but we can also do the LCM to find the lowest common multiple. So that's what we're going to do. We're going to find the LCM of the denominators. So you start with the prime factorization, 3 and 2 squared. You write every base you see. I see a 2, I see a 3, to the highest exponent you see it. That's 4 times 3, and the lowest common multiple, which is the lowest common denominator of 3 and 4, is 12. Now, you might have known that instinctively. You've worked with fractions before, and you've worked with common denominators. But when we don't know what the lowest common denominator is, we find the LCM of the two denominators. So we just talked about this. Let's rewrite these fractions with the LCD. So in other words, we want to rewrite these fractions with a denominator of 12. So you ask yourself, okay, what can I do to get from 3 to 12? What math operation? Well, I can multiply by 4. If I do it to the 3, I've also got to multiply to the numerator by 4 to keep the fractions equivalent. So that becomes 3 times 4 is 12, 2 times 4 is 8. Again, with the second fraction, 4 times 3 is going to give us the 12 we want for the denominator, but we also have to multiply the 1 times 3 and get 3 over 12. So we have rewritten these fractions. They are 8 over 12 and 3 over 12. They're equivalent. We talked about equivalent fractions in the last section. 8 over 12 is the same thing as 2/3, and 3 over 12 is the same value as 1 over 4. They are just written with the LCD, with the lowest common denominator. And we can use lowest common denominators to determine which fractions are bigger and smaller, because if their denominators are the same, it's pretty easy to say, well, okay, I know 3 over 12 is smaller than 8 over 12. So that's what we're going to do with these couple examples right here. So the first thing we need to do is find the LCD of 20 and 24, which means we need the LCM of 20 and 24, which means I start with the prime factorization. So 20 is 5 times 4, which is 2 squared times 5. There's 20. And 24 is 8 times 3, which is 2 cubed times 3, and box it up. So between these two prime factorizations, the LCM, I take every base I see, 2, 3, 5, to the highest exponent I see it. I see 2 cubed, I see 3 to the first, and 5 to the first. So that becomes 8 times 3 times 5. So I'm going to start with these two because the associative property says I can. 8 times 5 is 40, times 3 is 120. That is, crazy enough, the lowest common denominator for 20 and 24. So now we need to change these two fractions. Actually, I'm going to come down here. 120 and 120. We need to change these two fractions into equivalent fractions, but that have a common denominator of 120. So I asked myself, how can I get from 20 all the way to 120? Well, multiply by 6, because 6 times 20 is 120. But I also have to multiply the 11, the numerator, by 6 to get an equivalent fraction, and that's 66. So 11 times 6 and 20 times 6. What about this guy? How do I get from 24 to 120? Well, if you have a calculator, you can take 120 and divide by 24, and you get 5. If you don't know how to do it, you just long division it. So 24 times 5 is 120, and then you have to multiply 17 times 5. And what is 17 times 5? Let's see, 5 times 7 is 5, carry a 3, 85. So now I can compare these two fractions. Which one is larger? Which one is smaller? I go back to my original fractions, and I say, this guy is the largest fraction. He's larger than 11 over 20. But I didn't know that until I got a common denominator. So I want to work one more of these examples, and then we're going to talk about examples 12, 13, 14, and 15 in class. Again, I need to get a common denominator, and it needs to be the lowest common denominator. So I need the LCM of 18 and 21. Start with the prime factorization. 2 times 9, which is 2 times 3 squared in a box, and 3 times 7. LCM. We're not concerned about the GCF, so you don't even have to have but one side of the T-chart. Every single box I see a 2, I see a 3, I see a 7. And the highest exponent that I see for each one, so 3 would be squared. So 2 times 9 times 7, which is 2 times 63, so 63 doubled is 126. That is going to be our common denominator. So we're going to work with 126. Let me go down here, copy these fractions. 13 over 18 and 16 over 21. And I need these to be fractions that have a denominator of 126. So I have to figure out what the numerators are going to be. So you ask yourself, 18 times what goes into 126? Happens to be 7. If you have a calculator, you can use it. If I multiply the 18 times 7 to get 126, I have to multiply 13 times 7, and I get 91. That takes care of that fraction. How do I get from 21 to 126? It's 6. You might have been able to just see that. 21 times 6 is 126. 16 times 6 is 96. So these fractions are, look how close they are. They are not very far apart, and there would be no way to know that this guy was the bigger of the two unless you got this common denominator. They're just too close. 91, 126, the 96, 126, crazy. So this is one way that we can compare fractions to determine which one is bigger. Thanks for watching. We'll do the other 4 examples in class.